welcome to lesson 12.1, day 2. Today we are going to talk about mutually and non-mutually exclusive events. Mutually exclusive events are when we have the probability of A or B and they are independent of each other. So the outcome of A is not reliant upon B. Non-mutually exclusive is when there is some overlap. And again, these are not able to occur exclusively simultaneously because there is possible overlap. So for instance, if you are a cat versus a dog, like that is the pet, there isn't overlap. Like you don't have an animal that is a cat and a dog. But as humans, like we might just like cats, we might just like dogs, or maybe you like both your cat and your dog, right? There's that overlap. Those would be considered the non mutually exclusive type events. So, in each of the following, we are looking to decide is this a mutually or non mutually exclusive event? So, for the first one, there are 7 nickels and 4 dimes in your pocket. 5 of the nickels and 3 of the dimes are Canadian, the others are US. If we randomly select a coin, is it a dime or is it US currency? Well, that is going to have some overlap, right? A dime is a measure of the US currency. So you could be just a dime, but you would also be US currency, right? There's that potential for overlap. So this would be an example of something that is non mutually exclusive because you could be both at the same time. A dime that is US currency. The second example says a litter of kittens consists of 3 gray kittens, 2 black kittens, and 3 mixed color kittens. You randomly pick one. What is the probability that the kitten is gray or mixed color? Well, that's not going to happen where you are going to be able to get both things happening. It's either gray or it's mixed color. There is no overlap. So we would call that a mutually exclusive situation. In example 3, a litter of kittens consists of 2 gray females, 1 gray male, 2 black females, and 2 black males. You randomly pick a kitten. What is the probability that the kitten is gray or it's female? Well, it might be one of the 2 gray females. So, because there's that potential for overlap, we would call that non mutually exclusive. And then on the last one, a basket contains 5 apples, 3 peaches, and 4 pears. You randomly select a piece of fruit. Is it an apple or is it a peach? Well, there is no such thing as one that is overlap. You either are going to be one of the 5 apples or you're going to be one of the 3 peaches. So that's an example of something that is mutually exclusive. There are 2 examples for you to try. The first one says your roll of a fair-sided 6 dice either shows an odd number or a number greater than 3. Is that mutually exclusive or non-mutually exclusive? And then for number 2, a basket contains 5 apples and 5 peaches. One of the apples and 2 of the peaches are rotten. You randomly select a piece of fruit. Is it rotten or is it an apple? Is that mutually or non-mutually exclusive? On the next page, then, we talk about finding the probability of either event A or event B. So, first, we need to decide is this mutually or non mutually exclusive? Then we can decide on which formula to calculate. So, for instance, with our mutually exclusive events, we can just add those 2 probabilities together versus our non mutually exclusive, where we need to subtract away the probability of the overlap from their individual sums. So, for instance, when we have a deck of cards, right, there are 52 cards total, 4 different suits, 2 different colors amongst that. So, it says, what is the probability you select a queen or heart? Well, there are 4 queens out of our 52 cards. 13 of those 52 cards are hearts. And then one of those cards has an overlap of being something that is a queen and a heart. So we need to subtract it away. And then we can always reduce to get 4 over 13 as our probability. So in example B, it says again, standard deck of 52 cards. What is the probability that we draw the number 3 or 7? When we think about our deck of cards, we are not going to draw anything that is both a 3 and a 7. So this is a mutually exclusive event. Now there are 4 cards out of our 52 that are a 3. There are 4 cards out of our 52 that are a 7 for a total of 8 out of 52 or 2 out of 13 cards as our probability. What is the probability that it is a face card or a red card? Well, this is going to be non mutually exclusive because we can have face cards that are red cards. Think about like the Jack, King, Queen of hearts and diamonds, they are both. So, our face cards, there are three from each of our four suits, so a total of 12 out of 52 of the cards are face cards. And then out of those, there are 26 that are red, right? Half the deck is going to be red. Of those, the king, the queen, and the jack of both the hearts and the diamonds are going to cause overlap to be both of those things. So we would subtract that away, and you end up with 32 over 52, which reduces to be 8 over 13. What is the probability that you draw a 9 or a club? Well, there are only 4 cards that are 9s out of our deck, but there are 13 clubs in our deck. So we would add those two together. The overlap occurs when we have the 9 of clubs, which is just 1 out of 52 cards, for a total of 16 out of 52 or 4/13. Right, our last example has the probability of a king or a queen. Well, you cannot be a face card that is both a king and a queen. So again, these are going to be mutually exclusive, unlike our last examples. And this time, if I want a king, there are 4 of them each time. Same thing with our queens. There are 4 of them each time, for a total of 8 out of 52 or 2 out of 13. That would be the probability. So you're going to find the probability to find that you have a heart or a spade, a black card or a 2, and a jack or a diamond. Down on the last few tries, you have a bag that has the numbers 1 through 30 labeled. What is the probability of gaining an even number or an odd number out of those? And then for part B, what is the probability of drawing the 10 or a number less than 20? Okay, again, think if there's overlap or not. Thanks everyone for watching. We'll work more with these in class.